so I'm out of the way. Oh, someone. All right, let's start looking at this. We're going to identify our extrema. So looking at this left one, what do we have on this one as far as extrema goes? Say it louder. It's nonlinear. You're exactly right. Let's think about those extreme points, our minimums, maximums, those kind of guys. You are absolutely right, it is nonlinear. Let's keep going with the extrema. Do we have anything that's maximum-ish? At 0, 4, right? This guy. So that's max-ish. Is it an absolute maximum or is it a relative maximum? It never, ever, ever goes higher? I'm going to say, it's got this arrow up here. There's a little arrow right here. So this does continue up over here. So is this as high as it ever goes? No. It's relatively high. It's kind of high. It's a little mountain peak, but it is not the very highest it ever, 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 ever goes. So this is a relative maximum, which you can just put as an R max. You don't have to write out the whole thing of relative. How about, what else do we have on this one? A relative minimum. Where do we have a relative minimum? Yep, 2, 0. 2, 0. We are always going to list our points as ordered pairs. When in doubt, give me a whole ordered pair. Those are the only places on this one that it switches from increasing to decreasing or from decreasing to increasing, where it's changing directions, turns a corner. Those are where our extreme are. Any place it turns. So let's look at the right-hand one. What do we see? I was going to say, I heard something. I heard relative something, but I couldn't tell which one it was.
Absolute minimum.
Absolute minimum. Where do we have absolute minimum? -1, -1. Right here. And not 0, 0. We're still looking at that minimum. But at 1, -1, it's also an absolute minimum. So it can have more than 1 because those two things are equal. 1, -1. They're at the exact same height. So they are both absolute minimums. Last one. Yep, at 0, 0, we have a maximum. Is it an absolute maximum or a relative maximum? It is a relative maximum because it does go higher at some point. Okay? Questions on these guys? Okay. So what we're going to do today is we're going to finish out our last of our describing graphs in really weird mathy ways. With extrema and intercepts, we've done this with our all kinds of stuff. Because, you know that list we made in the bell work yesterday with the x-intercepts, y-intercepts, our extremas, and all those things. Starting tomorrow, I'm going to give you a list and have you draw a graph that matches that list. But we have one more thing we need to describe before we can do that. And that's called end behavior. And what end behavior describes are the arrows. So end behavior and I have 2 sets of graphs that I'll pass out to you guys in different kind of chunks as we get to them, simply because I want to make sure we have, plenty of space, plenty of time. We're not rushing, but also I'm not giving you 5 billion things. I'm going to test out the first set of graphs. Also make a set of graphs small enough that they for sure fit on a page. This is the graphiest of chapters. Put my copy down. Next. All right, so we're going to describe our arrows, and I'm going to start us writing it in people words, and then we're going to translate it into math. And this one feels very much like a foreign language kind of translation. It's going to feel Greek. Okay, so we're going to talk about our two arrows, because there's two arrows on here. And so my left arrow, I'm going to talk about first. So I'm going to write left arrow. And it's going to point which direction? Which direction does that point? Up or down? Up. So I need a way to say the left arrow points up. That's what we want it to say. And the way we do this involves no actual words because math is trying to be language neutral. So we say as x approaches, and we use an arrow, negative infinity. All this means is left arrow. As x gets real small, as x goes this way, this way, this way, this way, this way, our f of x, our y's, so f of x approaches up, positive infinity. As x gets real small and comes this way, this way, this way, my y's are going up, 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 up. That's what this means. This piece means left. And this piece means up. Left arrow, up. So we're going to do the same kind of thing for the right-hand piece. My right arrow points which way? Does it point up or down? Down. This guy points down. So our second arrow is going to be right arrow down. That's what we need it to say. I'm going to do my translation above. So this time, instead of x going to negative infinity and going left, I need it to go right. So my x's are going to approach positive infinity. As my x gets real big, my y's, or f of x, approach down, negative infinity. Bless you. And again, this piece, whoa, that was trash, means right arrow, and this piece means down. That is what they mean. When we're doing this, like for realsies, we're only going to write these purple pieces. We don't need to write the left arrow up, right arrow down. It was just so we could see what was happening here and kind of what our our translation is. We're going to practice this a bunch of times. But questions on the first one? And we will continue to use this throughout the year. So this is not just like a one and done. We will use end behavior for sure next semester. I think we continue to use it throughout the semester as well, especially when we get into chapter 3. All right, let's look at the next one. I still see a bunch of people writing those, so I'm going to give you guys another second. So if you're done writing, look at the next picture. See if you can figure out which direction our arrows are going. Both arrows are pointing up. Yep.
So it's
All right. So I almost always start with my left arrow just because we read left to right. It doesn't really matter. You can do them in whatever order you wish. I just tend to go left to right because that's the way we're used to reading. So my left arrow is pointing which way? Up. So the way we say left arrow is as x approaches negative infinity. As my x's get real small, what happens to my y's? They get big. So my y, or in this case it's called my g of x because it's labeled on the graph over there. G of x approaches which one? Positive infinity. Good. Yes. Positive infinity. Because as my x's get real small, my y's go up. So then let's do the right arrow. My right arrow is also pointing up. So we have as x approaches positive infinity, as my x's get real big, going out that way, my y's are also going up. So my g of x approaches positive infinity. And the only reason I switched to using g of x instead of using f of x or using y is because it was labeled over here and said, hey, this one's name is G. His name is George. That's all it means. He's got a G name. The first one had an F name. He was Frank. So we had Frank, now we had George. It's the only difference between f of x and g of x. They just have a different name.
so when it's negative, it's a left arrow. When it's positive, it's a right arrow.
On the x's, correct.
So then what about the y?
If it is negative, it's pointing down. If it's positive, it's pointing up.
Okay.
And it's all about the relationship between them. So it's similar to domain and range, but not exactly the same, but it's similar. It's all about the relationship between the x's and what happens to our y's. Okay. Let's look at another one. These don't take super long. We just have to get our feet underneath them, and that's why we practice them a bunch. Because they're awkward, but they're not awful. Okay. So now this one's name is y instead of f of x or g of x. So we're just going to call him y. And that's okay. So we're going to describe our arrows. Which one do you want to start with, left or right? Left. My left arrow points which way? Down. Gorge. So my left arrow we say as x approaches negative infinity. Good. My y approaches negative infinity. It's going down. I'm yelling timber. I don't want to tic-tac too much. Okay. So as x approaches negative infinity, as my x's get real small, my y's get real small. They're going down. I'm yelling timber. How about for my right arrow? How are we going to put that? Up. So as x goes to infinity, y goes to, look at this one, we're going up. So regular infinity, positive infinity, it's going up. My y's are getting real big.
No, look at the first one. See, it's different. The first
So, yep.
one-
So the first one says x's get real small. So as my x's keep going this way, my y's are going lower and lower and lower. And on the right hand one, it says my x's get big. So as I go this way, my y's are going up.
Oh, wait,
As
I
X
see.
gets bigger.
There we go.
I see.
Awesome.
When they go up.
Yes. I'm always happy to explain in more ways. Always, always, always. Usually that involves me throwing my body around in some way, shape, or form. Okay, I want to practice a few more because some of them look a little weird, but I wanted us to get our feet under us before I toss you a couple weird ones. Okay? So we're going to do 3 more, and then that'll be it. And we'll have whatever time we have left to work on homework and catch up on stuff, okay? We're going to do 3 more, but it also then makes it fit on your page a whole lot easier if it's on 2 separate little sheets instead of in one gargantuan sheet. How do you make this real happy? Not you. I'm just telling you that around individual things. Yeah. That's okay. Leave it on the table. I have another algebra class next period. And I usually wind up with spares because these things stick together, especially after I cut them. Stabbing on them gets really.
She got it, man. She got it, man.
All right. Told you I was going to toss a couple weird ones at you. So the first one's not super weird. That is not the next one. There we go. Oh, it's because that one's duplicated. Love that. Delete that page. Boop. There we go. That one. And the label's not on there, but this one's called f of x. F of x. That's just his name. His name's Frank. Or Fred. Or Felicia. Maybe it's Felicia. Bye, Felicia. Probably should have made this one be upside down, but oh well. Too late, no. All right. How are we going to describe our end behavior on this one?
X goes
As x.
as X goes to positive.
Positive infinity. Let's go ahead and do it. Which way does my f of x go?
F of X goes positive.
Goes to positive infinity. That was the right arrow. Y'all are switching it up, and that's okay. Absolutely fine. As x goes to positive infinity, right arrow, f of x goes up. Do you see that? How about our other arrow? Also approaches positive infinity. Good. As x approaches negative infinity, f of x approaches positive infinity. So I have on the top right arrow up. On the bottom I have left arrow up. Questions on this one? Okay. We got 2 more. That's it. So this one's real wide. Real wide. Which throws us off a little. Not entirely sure why, but it does. So let's take a peek-see here at f of x. Actually, I do know why, but I kind of did it intentionally. So what do we think about our end behavior here? This left arrow, which way is it pointing? Up. Even though it looks partly sideways, it's still going up. So we're going to have our, as x approaches negative infinity, it's still my left arrow. This one's called f of x, so I'm going to put my f of x approaches positive infinity. My left arrow is pointing up. Even though it looks kind of sideways, it's still going wonkily up. Wonky up is still up. Yes, my dear?
He's going up.
This is left arrow, so as my x's get real small, as we go this way, this way, this way, my line's going swooping up and up and up. I might trip over something. Whoop. As I keep going this way, my line's going to go up, 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 and up and up and up, that way, right? So my y's are getting bigger. So my y's are going to approach positive infinity. Because if I go over here to negative 1 million, my y's way up there in the upper atmosphere, super duper high. So it's getting way, way, way big. So it's just saying what happens when my x's are gargantuanly to either end. Okay? Cool, cool, cool. Let's do our other arrow on this one. What do we have on our other arrow? As x, positive infinity, gorge, approaches negative infinity. Absolutely beautiful. Because my right arrow, as my x's go the other direction. Now we're going to positive infinity. We're going this way. And my whole function is starting to fall. And it's going to dig through the ground. And it's going to go underground. We're going subterranean. We're going to go through the planet. Out the other side. And so it's going down to negative infinity. Okay? Questions on this one? The last one is the weirdest one. Okay? Not a super common thing, but a thing that can happen. Because instead of this one being, this one's kind of wonky up. It's kind of up, but mostly sideways, but kind of up. This one's straight up sideways. And this one's a straight up horizontal line. There's no up, there's no down, it just is. So before we get to end behavior, I want us to think about some values here. If my x is 0, what is the value of my y? 2. If my x is negative 4, what's the value of my y? 2. If my x is positive 4, what's the value of my y? If my x is negative 10, what's the value of my y?
2.
If my x is positive 100, what's the value of my y?
2.
2. So if my x is negative a million, gazillion, bajillion, what's my y? 2. So as my x approaches negative infinity, what's my y?
2.
Okay, so that's our end behavior for it. Is always going to do the whole sentence, but instead of infinity, it's going to be that 2. Because as my x gets super duper small, it's staying right here at 2. It's staying. So as x approaches negative infinity, I started with left. My g of x, because it has a name, it's Greg. Greg approaches 2. It's at 2. It is stuck at 2. It's going to be 2 forever and ever and ever and ever. This only happens with horizontal lines. For us. If you get into calculus, it does all kinds of fun, weird things later on. But for us, it's only going to happen with horizontal lines. Until May. All right, so then let's do our right arrow. Same thing. As my x gets real, real big, if I choose my x of 1, we're at 2. My x of 5, we're at 2. My x of 100, we're at 2. My x of 1,000,000, we're at 2. My x of infinity, we're at 2. So as x goes up to infinity, g of x, Greg, my g of x approaches 2. I Again, it's not going to be a super common thing that shows up. More often than not, we're going to have infinities. Because for the most part, what we deal with goes up in some way, shape, or form. It's rare, but it's a possibility. And honestly, I don't write most of the homeworks, so I don't want someone to pull a weird out on you and throw you off. Okay? Questions on our end behavior? End of day. Y'all have more than 10 minutes. Work through homework 3. If you don't have a copy of homework 3, I have extras over here. I know when I passed mine on Friday, I had a lot of people not pick them up. So I'm going to put them up here on the table. That's the one that has the extrema on it. It also has end behavior. So work through both of those. Ask questions if you got them. I'm going to pass out some homework while you guys work, but feel free to stop me and ask questions, okay?